Hi everyone, and welcome to the Mat 211 review of Measures of Central Tendency. My name is Julia, and I work for the tutoring centers at ASU. So, X is the sum of the result of rolling two distinguishable dice. Calculate the expected value, E of X, of the random variable X. So the first thing we need to do here is we need to figure out our probability distribution, so our table, of all the different possible probabilities for X. To do this, let's table the results that we can possibly get for X with these two distinguishable dice. So we'll just make a little table here. We're going to have 1, 2, 3, 4, 5, and 6. So that'll be one of the die, because remember they're distinguishable. So if one of the die has 1 and one of the die has 2, that's not the same thing as if the first die in this case has 2 and the other one has 1. Those would be considered two different events in this case. So then our second die is 1, 2, 3, 4, 5, 6. And this 1 through 6 on each side just represents the possible rolls that you could get from each die. So now we know that X is going to be the sum of each of these die. So we'll have 2, 3, 4, another 3. We'll have 4, 5, 6, 7. Then in this row, we'll have 5, 6, 7, 8, then 4, 5, 6, 7, 8, and 9, and let's see, 5, 6, 7, 8, 9, and 10. That is a 9. 6, 7, 8, 9, 10, and 11. And for our last column here, we've got 7, 8, 9, 10, 11, and 12. So those are all the different possible outcomes that we could get from each of the different possible combinations of our two die. So now we want to calculate our table of all of our different possible outcomes. The first thing to note is that the cardinality of our sample space, which means the number of different possible events here, is 6 times 6, or 36. So there's 36 different values in this table, representing 36 different events, even though some of those events do end up with the same number. So we know that we're going to have 36 total events, or possible events. And for each value, we want to count up the number of times that that value occurs and divide it by 36 to get its the probability of getting that particular event. So we have little x here, which is going to represent each of our possible values in here. And then we have the probability of big X being little x. Well, that's going to be, for our little x, we would have 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Running out of room there. Let's see if we can squeeze that in a little bit more. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Good enough. Now we want to calculate the probability of each of these. So note that 2 through 12 are all the different possible values in this table. And we can go ahead and just mark each set of each different values. So we've got 1, 2 here. We've got 2 3s, 3 4s, 5 6s, or 4 5s, excuse me, 5 6s, there we go. 6 7s, 5 8s, 4 9s, 3 10s, and 2 11s, and 1 12. So our probabilities will be, well, we have one way of getting 1 out of 36 ways, we get a 2. We have 2 out of 36 ways, we get a 3, and so on and so forth. We got 3 over 36, 4 over 36, 5 over 36, 6 over 36 for our 7s, 5 over 36 for our 8s, 4 over 36 for our 9s, 3 over 36 for our 10s, 2 over 36 for our 11s, and 1 over 36 for our 12s. So now that we've got all of our different probabilities calculated, now we want to calculate our expected value. So our expected value, remember, is going to be the sum of from I equals 1 to n, where n is the number of different possible outcomes for little x, of little x, so each little x here, times its associated probability, which is the probability that big X takes that value of little x. So in this case, we're going to have our first value of little x here is 2 times its associated probability, 1 over 36. So 2, 1 over 36, and then we'll add to that our 3 times our 2 over 36. 3 over, oops, that's a 2 over 36. Let's erase that and make that neater looking so we can actually read it. There we go. And then we've got 4 times its associated probability, 3 over 36. So that's 4 times 3 over 36. And we'll keep going just like this. So we've got 5 times 4 over 36 plus 6 times 5 over 36 plus 7 times 6 over 36 plus 8 times 5 over 36 plus 9 times 4 over 36 plus 10, almost there, plus 3 over 36 plus 11 times 2 over 36, its associated probability, and lastly, plus 12 times 1 over 36. So we're just reading across each value of this table, multiplying those together and summing them all up. Now, we could do some tricks to maybe simplify this equation a little bit, but I just went ahead and plugged it into my calculator. And the value that I got was 7. So 7 is our expected value of big X from this probability distribution. So note that 7 is one of our values this time. That's not always going to be the case, but in this case it's true. And that's to be expected because if we look, we have symmetric numbers and symmetric probabilities around our central number here. And so it's kind of spread evenly on either side of it. So it makes sense that it's 7 in this case. So that's it. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring for your specific course, you can use our tutor search tool, which you can find at our main webpage here, or by following this full link here, which will take you right to the tutor search page. So thanks so much and have a great rest of your day.